We're diving into a story that honestly feels like it's straight out of science fiction. It's about a dream that was once laughed at, a quest to build an artificial general intelligence, and it's a journey that started in a university basement and ended up solving one of the greatest mysteries of life itself.
So let's get right into it. This whole epic story really begins with a goal that is so ambitious, it's almost hard to wrap your head around. To build artificial general intelligence, or AGI. We're talking about a single system that can learn and do basically any cognitive task that a human can.
In this quest, it really started with two minds, Dimas Hassabis and Shane Legg, who met at University College London. They pretty much immediately bonded over this shared obsession, this challenge so huge it sounded, well, kind of absurd. They wanted to solve intelligence itself, and then use that solution to solve everything else.
But you have to understand, back in those early days, their incredible vision just slammed into a wall of skepticism. AI was almost a dirty word in serious science circles. If you told someone you were working on it, they'd kind of look at you funny. The dream was just too big, too out there for the academic world at the time.
So they did what you do when academia isn't working out. They decided to start a company, DeepMind. And can you just imagine walking into an investor meeting with this pitch? You're asking for a ton of money with a ton of risk for something that might not even be possible in the first place.
And this quote just nails the rejection they faced over and over. They'd lay out this grand, world-changing vision, and the investors would just hit them with these really practical, almost boring questions. The dream was just way too big for the traditional business world to even process.
So how in the world did they get past this hurdle? Well, they found a way forward by doing something really smart. They turned to something we all know, games. See, they saw games not just as fun, but as these perfect little self-contained worlds to train a general learning machine. And their secret weapon, their core method, was something called reinforcement learning. The idea is actually pretty simple, but it's incredibly powerful. You've got an AI agent and you put it in an environment, like a video game. The agent has no idea what the rules are, it just knows it gets points for doing good stuff. So it learns completely from scratch, just by trying to get the highest score possible.
And this is where we see their first huge breakthrough. They built one single algorithm called DQN, and they just let it loose on a bunch of classic Atari games. It wasn't programmed for any specific one. Take the game Breakout. After just a few hundred games, it was already as good as a human. But then, they just let it keep playing, and it discovered a strategy that no human player had ever thought of, digging a tunnel through the bricks to send the ball up behind the wall. It was that first little spark of a new, creative kind of intelligence.
So, with this success under their belt, and now that they'd been acquired by Google, the DeepMind team set their sights on a challenge that for decades was considered the absolute holy grail of AI.
The game of Go. This is a game of just profound complexity and intuition. It's so complex, in fact, that there are more possible moves than there are atoms in the known universe. Just let that sink in. Brute force computing, the kind that beat chess, was totally useless here. They were going to pit their AI, AlphaGo, against the legendary world champion, Lee Sedol, in a historic 5-game match.
The tension was just off the charts. The whole world was watching. And nobody, not even the DeepMind team, was sure what was going to happen. They thought Lee Sedol would probably win, but they were hoping AlphaGo would at least put up a good fight.
Then, in Game 2, something completely unbelievable happened. AlphaGo made a move, it's now famous, Move 37, that was so unexpected, so weird, that the team calculated the probability of a human expert playing it was just 1 in 10,000.
The commentators were just speechless. Lee Sedol himself got up and left the room to try and compose himself. It was this moment of just pure, unexpected creativity coming from a machine. It wasn't just calculating, it was showing a kind of intuition that totally changed the game forever.
And here's the crucial point. This wasn't just about winning a game. For so many people, this was the Sputnik moment for AI. It was a wake-up call for the entire planet that a new kind of intelligence had arrived, one that could learn, strategize, and even create in ways that went beyond human ability. A global AI race had just begun.
Okay, so they've conquered games. The world is finally paying attention. What do they do next? Well, DeepMind pivoted. They went back to their original mission and took on one of the biggest challenges in all of science, a problem that Dimas Hassabis had been obsessed with since he was a student.
This is the grand challenge of protein folding. So what is that? Basically, proteins are these tiny little biological machines that run everything in our bodies. And if you could predict their 3D shape just from their genetic code, Well, you could unlock the secrets to curing diseases, designing new medicines, everything. But for 50 years, it had completely stumped researchers. Now, their journey to solve this with a system called AlphaFold, it was not a straight line. They entered the field's Olympics, a competition called CASP, in 2018. They won, which was great, but the feedback they got was, well, humbling. Biologists told them the results weren't quite useful enough yet. So they went back to the drawing board, completely rebuilt the entire system, and came back in 2020. And this time, the results were so good, the competition organizer sent a simple email that said, "After half a century, we finally have a solution."
And what they did next was truly extraordinary. Think about it. They had this world-changing technology. They could have patented it, sold it, made billions. But they didn't. They ran AlphaFold on every known protein in existence, over 200 million of them, and they released the entire database for free as a gift to the world.
The success of AlphaFold, it really marked a whole new era. This wasn't about beating a human at a game anymore. This was about creating a tool that could accelerate science itself, a tool that could solve problems that humanity had been stuck on for decades.
And this chart just puts the incredible scale of that breakthrough into perspective. Just look at this. On one side, you've got over 50 years of hard, painstaking lab work, which determined the structures of about 170,000 proteins. And on the other side, AlphaFold. In about a year, it predicted over 200 million. The acceleration of scientific progress is it's on a scale we've never seen before.
Which brings us right back to that original mission. AGI isn't some distant sci-fi dream anymore. The very same principles that mastered Go and solved protein folding are now being used to build even bigger, more capable systems. We are right on the cusp of something that is going to fundamentally change, well, everything.
This whole journey, from a rejected idea in a university basement to literally solving the code of life, it shows you the incredible power of a single, focused mission. It's a technology that could be bigger than electricity or fire, and it leaves us with what is maybe the most important question of our time. As we all get ready for this new chapter, how do we get